In this video, we are going to see what is set cover problem. So it is a concept of greedy algorithm. What is a set cover? The set covering problem is a significant NP-hard problem. What is NP-hard problem? There is no polynomial time solution available. Given a collection of elements, the set covering problem aims to find the minimum number of sets that incorporate all of these elements. That is, it covers all these elements in the set. Let us see an example of what is set cover problem. In this example, we are given with an union, set and the respective cost. So the actual aim of a set cover problem is to find the minimum set cover. Let us see them in detail. The condition for the set cover is to check whether the sets are equal to the union or not. So first we are going to check S1 union S2 is equal to union or not. If this condition is satisfied, we have to find the cost, followed by the next conditions. To make it more understandable, let us consider S1 as one particular train station and the values 4, 3, 1 are the passengers, similarly followed by S2 and S3. Like S1, we are considering S2 as another station and we are going to union the values of set S1 and S2. After doing the union operation for the set S1 and S2, we have arrived at the solution that union values of set 1 and set S2 are equal to U. So as per the condition, if sets are equal to union, we have to find the cost of them. S1 union S2 is equal to U, so we need to find the cost of them.
So the value of S1 is 5 and the value of S2 is 10. So 5 plus 10 is equal to 15 is the cost of S1 and S2.
We have find the cost as 15 since S1 union S2 is equal to U. So next we are going to perform union operation for the sets S1 and S3 and check if it is equal to U or not. So similarly to the previous scenario, here S1 and S3 are two different stations. And we are going to perform a union operation with S1 and S3 values. Checking for the condition, if S1 union S3 is equal to U, the values of S1 union S3 are not equal. So the condition is failed here. Since S1 union S3 is not is equal to U, we don't have to find cost here. S1 union S2 was is equal to U, so we find the cost for it. S1 union S3 was not equal to U, so we did not find any cost here. So for the next condition, we have to check S2 union S3 is equal to U or not. So again, S2 and S3 are two different stations. We are going to perform union operations. So yes, with the values of set S2 and S3, we are going to perform union operations. After performing the union operations for the set S2 and S3, the value of S2 union S3 is equal to the union values. Since S2 union S3 is equal to U, we have to find the cost of S2 and S3. So now for finding the cost, we have already given with the cost values of S2 as 10 and S3 as 3. By adding 10 plus 3, the cost value of S2 and S3 is 13. Since S2 union S3 was is equal to U, we have found the cost as 13. So now we have to find whether S1 union S2 union S3 is equal to U or not. Same as before, but here we have three different sets S1, S2 and S3. We are going to perform union operations for all three sets and arrive at some solution, whether it is equal to U or not. So the value of S1 union S2 union S3 is equal to union value and the condition is satisfied. Since S1 union S2 union S3 is equal to U, we have to find the cost of them as we did previously. The S1 value is 5, the S2 value is 10 and the S3 value is 3. So to find the cost, we have to just simply add it. So 5 plus 10 plus 3 is equal to 18. So the cost of S1, S2 and S3 is 18. Since the condition is satisfied, the cost of S1 union S2 union S3 is found as 8n. And so we have almost arrived to the conclusions. From the beginning of the problem, we have been finding out and performing union operations for all kind of set values, and we have arriving the cost for each of them. Now we have to find the minimum cost for it. The minimum cost is 13 and it belongs to the set S2 and S3. The aim of the problem is to find the minimum set cover. By finding out the minimum cost, we have arrived at the solution that the minimum set cover is S2 and S3. This is the time complexity of set cover O of nm. N is number of elements in U and m is number of sets in S. So that is all about the set cover problem. Thank you.